frequency identification. It is a wireless technology that uses radio waves to transfer data between a tag and a reader. RFID helps identify and track objects automatically without physical contact. Unlike barcodes, RFID does not require direct line of sight scanning, making it faster and more efficient. Today, RFID is widely used in transportation systems, shopping malls, hospitals, security systems, and many other industries.
Hi everyone, my name is KHADIJAH and I'll be presenting to all of you about the history of RFID as concise and as interesting as I could. So without further ado, in the 1940s, where RFID first started to be used in the military to identify friendly craft with the help of something called IFF, Identification Friend or Foe. Secondly is during the 1970s where commercial development started, where Mario Cadulo are the first one to patent RFID tag that is then used for electronic tolls by vehicles on the roads. Thirdly is during the 1990s where RFID start to be used in supply chain and businesses to quickly input a whole lot of goods into the system using something called EPC, which is electronic product code on the items. And last but not least is during our present where RFID are used in smart system and IT integration, with the simplest example of us using credit card to pay for the things we want with just a simple tap, using something with the help of something called NFC, Near Field Communication, which is a subset of RFID. So, in conclusion, it is clear that RFID had advanced from being a military tool to something that we use in our daily life. That's all from me, thank you.
An RFID system consists of four main components. The first component is the RFID tag. The tag is attached to an object. It stores data in a microchip and has an antenna to receive and respond to signals from the reader. The second component is the RFID reader. The reader has an antenna that sends radio wave and receives response from text. It encodes and decodes data and controls communication with text. The third component is the antenna. The antenna transmits radio wave from the reader and receives signals from the text. Finally, the backend system. The system processes the data collected by the reader. It may include middleware, database, and application for managing and analyzing RFID data. So, how RFID works? First, an RFID tag contains a microchip that stores information and an antenna that sends and receives signals. The tag is attached to an item such as product, ID card, or vehicle. The RFID reader then uses an antenna to emit radio frequency signals. This radio wave activates the RFID tag when it comes within range. The tag receives the signal and sends back its stored data to the reader using radio wave. The data may include product ID, serial number, location information, or user information. Finally, the RFID reader captures the response from the tag and converts it into digital data. The information is sent to a computer or database system for tracking, monitoring, inventory management, or access control.
Next, types of RFID tags. There are three main types of RFID tags. The first is a passive RFID, which does not contain a battery and receive a power from the reader signal. Passive tags are cheaper but have a shorter reading at distance. The second is active RFID, which use its own battery and can communicate over longer distance, but it is more expensive. The third type is a semi-passive RFID, which combines features of both passive and active tags. Next is application of RFID. RFID technology has many applications in our daily life. For example, RFID is used in the access card for office and universities. It is also used in the toll payment system like Touch and Go card. In retail business, RFID help track product and inventory efficiently. Hospitals use RFID to monitor patient and medical equipment. Libraries also use RFID for automatic books tracking and a borrowing system.
Moving on, let's look at the core benefits of this technology. There are several major advantages to implementing RFID system, primarily centered around speed and efficiency. First, we have fast scanning. Unlike traditional barcode that require a workers to scan items one by one, and RFID readers can scan hundreds of tags simultaneously in a matter of seconds. Second, no line of sight is needed. Because RFID uses radio wave, it can read text through cardboard, plastic, or woods. This means a worker can scan an entire shipment inside a seal box without ever opening it. These two factors lead directly to high accuracy and save time. Automated scanning drastically reduces human error like miscount or data entry mistakes. Ultimately, it turns inventory tasks that used to take an entire day in process that takes just a few minutes, saving organization and immense. However, to get a complete picture of RFID, we also need to balance this benefit against its practical challenges, which bring us to the disadvantages. The first major hurdle is that RFID can be quite expensive. The initial investment for the readers, the specialized software, and the tags themselves is significantly higher than the standard barcode paper stickers. For a smaller businesses, this upfront cost can be hard to justify. Next are the privacy issues. Because these tags can be read remotely from a distance, it raises data security concern. There is a risk that unauthorized readers could skim information from tags, leading to concern about consumer tracking or data leaks. Finally, we have to deal with signal interference. RFID relies entirely on radio waves, which are notoriously disrupted by physics. Metallic surface will reflect the wave and liquid will absorb them. If you are tracking metal parts or beverages, the system reliability drops, making environmental setup quite challenging.
Now we're going to talk about RFID and physics concept involved. There are three major concepts, which is electromagnetic wave, signal transmission, and electromagnetic induction. Let's look at electromagnetic wave. RFID doesn't use wires, instead it uses radio waves, which are a type of electromagnetic wave. Think of electromagnetic wave as the invisible highway in the air. Instead of using wire to connect the reader and the tag, information travels through this wave. Now, for the signal transmission in RFID, it relies on the wave equation, which is V equals to frequency lambda, because radio wave always travel at the speed of light, changing the frequency and changes the wavelength. This physics principle dictates how close you need to hold a tag to the reader and how fast the data can be read. Last but not least, the electromagnetic induction also involved in RFID. RFID tag doesn't have batteries, which they still need power source. When the reader electromagnetic wave passes through the tiny antenna, it creates a small electrical current. This is induction, which turns the magnetism into electricity wirelessly. Now, we're gonna talk about RFID and its future development. When we look at RFID, the biggest changes are actually happening to the physical tag themselves. The rise of flexible and wearable RFID and eco-friendly tags are such a good use. Scientists are creating stretchable tags that can be worn on the skin for medical tracking like vital signs, while using paper and wood fiber so the tag can be recycled safely without creating electronic waste. By this tag can safely decompose in a normal compost pile or be recycled alongside the standard paper cardboard. In conclusion, RFID is an essential wireless technology that uses radio wave for instant identification and tracking. By relying on the core of physics, specifically electromagnetic wave and induction, RFID eliminates the need of manual scanning and wires. Today, it is widely applied in modern industry to boost efficiency and automation. As the technology evolves to become cheaper and more flexible, RFID will play an even greater role in shaping our connected future.